In an unbiased PN junction, unbiased potential at P is less than the potential at N. During isothermal process, temperature of the system remains constant. Next question, students. The mass of two radioactive substances are same. There are two radioactive substances which have the same mass, and their half-lives are 1 year and 2 years respectively. The half-lives are given 1 year and 2 years respectively. The ratio of their activities after 6 years. So the disintegration time is 6 years. I have to find the ratio of their activities, for which I used a simple shortcut. Activity A is A naught half. Here T denotes the disintegration period divided by T half, which is the half-life. So A equals A naught half T divided by T half. In the first case, A1 equals, however, A naught gets cancelled, half. Disintegration period is 6 divided by half-life is 1. So here, students, activities after 4 years has to be calculated. Disintegration period has to be 4. So this is 4 divided by 1. So A1 is half to the power 4. Similarly now, A2 is equal to half. Disintegration period is 4 divided by 2, or this is half to the power 2. A1 by A2. So when I take the reciprocal, it becomes 2 by 4 or 4 by 2. So the answer is 1:2. 2 by 4 you get. So 1:2 will be the answer. To find the number of alpha and beta particles emitted, Soddy's group displacement law. Again, every successive paper I have done, third option will be the answer. The most stable particle in the baryon group, again elementary particles, the previous syllabus, the answer is proton. In an unbiased PN junction, unbiased potential at P is less than the potential at N. To get an output, Y is equal to 1. What should be the inputs across A, B and C? Simple digital electronics. 1, 0, 1. The next question. I have to calculate the dimensional formula for gravitational constant capital G. Dimensional formula for gravitational constant. Any expression which will give me gravitational constant, Newton's law of gravitation, where we wrote gravitational force is equal to G m1 m2 by r square. Recall Newton's universal law of gravitation. F equals G m1 m2 by r square. I want the dimensional formula for G. So G will have the dimensions, cross multiply dimensions of force into dimensions of r square. This is m into m, dimensions of m square. Force ml t minus 2, mass into acceleration, L square divided by m square, which is m goes to the numerator. This is 1 minus 2 plus 1, m minus 1 L cube t minus 2. So m minus 1 L cube t minus 2 is the answer. Next one, interesting. A body is projected vertically upwards. A body is thrown vertically upwards. The times corresponding to height while ascending and descending are T1 and T2 respectively. Andre, time taken by the body to reach the maximum height, time of ascent is T1, and the time taken by the body to come back, time of descent is T2. We have to calculate the velocity of projection. Now, we know that during projection, time of ascent is always equal to time of descent. So T1 is equal to T2. Now I use V equals U plus GT. It reaches maximum height. Final velocity becomes 0. So U equals GT or T equals U by G. So the time of ascent or descent is U by G. So total time is T1 plus T2, which is 2U by G. U by G plus U by G, which is 2U divided by G. So T1 plus T2 is 2U by G. T1 plus T2 into G by 2 is U. So the answer is the fourth one, T1 plus T2 into G divided by 2. Next one. A mass of 10 kg is suspended using a spring balance. Some mass of 10 kg is suspended using a spring balance. So vertically though, spring balance, a mass of 10 kg is suspended. It is pulled by a horizontal string so that it makes an angle of 60 degrees with the vertical. Now, it is pulled by a string which is making an angle of 60 degrees with the vertical. What is the new reading of the spring balance? Now, the downward force is the weight which is mg, and this mg should be equal to T cos theta, the tension T cos theta, or T is mg by cos theta. M is 10g, cos 60 is half, so this is 20 kg weight. So the new reading is 20 kg weight. See, simple. Just know the way to solve, and some linear expressions we can solve this. This is from the previous syllabus. It requires some thought. Since you're not exposed to the theory, I don't take this for discussion. The next one. A body of mass 4 kg is accelerated by a constant force. There is a body of mass 4 kg which is accelerated by a constant force. Data number 1, the mass of the body is given. It travels a distance of 5 meters in the first second. It travels a distance of 5 meters in the first second and distance 2 meters in the third second. Then the force acting on the body. My dear students, the moment the word mass is defined, force has to be the product of mass and acceleration. Which means the whole show here is to calculate the acceleration of the body. Ye gaman se, distance 5 meters in the first second and distance 2 meters in the third second. This is an exclusive example for motion in the nth second. Distance traveled by a body in the nth second of its motion. What is the expression for distance traveled in the nth second? So Sn equals u plus a by 2 into 2n minus 1. Please note this, the distance traveled by a body in the nth second, Sn equals u plus a by 2 into 2n minus 1. In the first case, what is the distance traveled? 5. I keep the velocity u, a by 2. In the first second, Now n turns out to be 1. So 2 minus 1 is 1. Second case, distance traveled is 2. Again, u plus a by 2. 2 into 2, 4 minus 1. I'm just substituting here. Simplify this. A turns out to be minus 6 by 4. So on substituting, 4 into minus 6 by 4. So 6 Newton is the answer. Again, done umpty number of times. 4 sessions I have done this. So plus 3G will be the answer. The ratio of specific heats is gamma. R is universal gas constant. Then the molar specific heat at constant volume, CV, has to be calculated. The moment I say specific heat, what is that comes to my picture? Yes, Mayer's equation. Cp minus Cv is equal to R. ಇದನ್ನೇನು ಕರಿತೀವಿ? Mayer's equation. Specific heat at constant pressure, specific heat at constant volume are universal gas constant. Also, gamma is the ratio of specific heats. So, gamma is Cp by Cv, or gamma into Cv is Cp. Substitute. Cp is gamma into Cv. So, gamma Cv minus Cv is R. So, Cv is gamma minus 1 equals R, or Cv is R divided by gamma minus 1, which is the third option. Again, the work done. So, work done is the area under this triangle, half base into height. Half base is 3V1 minus V1, which is 2V1. Height is 4P1 minus, this is 3P1. 2 and 2 gets cancelled. So this is 3V1P1, but with a negative sign. Why negative sign? The process is happening in anti-clockwise direction. Therefore, we have taken negative sign. In which of the process internal energy of the system remains constant? It is isothermal. During isothermal process, temperature of the system remains constant. Since temperature does not change, internal energy also remains constant. This is very much done in the previous session itself. 75 degrees Celsius is the answer. Rearranging the given equation, 6 sine 4 pi t minus 0.2 pi x, which is y equals a sine omega t minus kx. Compare here. K is 0.2 pi. So this is 2 pi by lambda is 0.2 pi, which means lambda is 10 millimeters. So I've got the value of lambda. We know phase difference is 2 pi by lambda into path difference. 2 pi by lambda is 10 millimeters. Path difference is 2 millimeters. Yeah, so this goes 5 times. 72 degrees is the answer. With what velocity should an observer approach a stationary sound source so that the apparent frequency is double the actual frequency? He says, see, by Doppler effect, f dash is v minus, good, divided by v naught, v minus vs into f. Now, the apparent frequency f dash is double the actual frequency. 2f is v minus v naught, v minus 0, because very clearly it is a stationary source. Source is at rest. So this is f. So which means v naught is minus v. The negative sign indicates that it is moving opposite to the direction of the velocity of sound. Stephen's law. E is directly proportional to t to the power 4. So E1 by E2 is equal to, so 27 plus 273, 27 plus 627 to the power 4. Simplify, get the option. This last two is actually from the previous syllabus. Intensity, this is 1000. So very clearly, we have bisected, analyzed the 2008 paper. Next, I come back with 2007 paper. Thank you.